Hi everyone, welcome to our second to last section of the unit, scientific notation. A lot of people usually tell us that they did this a couple years ago in middle school, so let's see what you remember. So I wrote you a little background, of course. Scientific fields and industry use metric units because calculations are easier with powers of 10. People always ask, well, when am I ever going to use this? Well, you might not use it, but people in the real world actually do. It's also why metric units based on powers of 10 are widely used in science, because it's easier to use scientific notation than writing out really big and really small numbers. So here's what you're responsible for. Let's go through the few examples that I have here. So writing a number in standard form, when we ask you to do that, that just means writing the number out with all of the zeros. So when I haven't actually told you what scientific notation is yet, but when I give you something like this, 5 times 10 squared, well, you know, after working with exponents, that 10 squared is 100. So I'm really doing 5 times 100, which is 500. So how does 500 relate to 5? Remember, over here at 5, the decimal point's right here. Over here at 500, the decimal point is here. So what happened? We added on 2 zeros to get to 500. Those 2 zeros came from your exponent. And we'll solidify this rule in a minute. Number 2, if you had 8.23 times 10 to the 4th, that's really saying you're doing 8.23 times 10 to the 4th. Remember, that means 10 times 10 times 10 times 10, which is 10,000. It's a 1 with 4 zeros. And if you multiply that out, that gives us 82,300. Decimal places here at the end. Over here it was at 8.23. So how did we go from a decimal point between the 8 and the 2 all the way to the end here? Well, we moved it over 1, 2, 3, 4. These empty spaces here are where we put the zeros. And the 4 spaces comes from your exponent. Now let's look at some negative exponents. 4 times 10 to the negative 1. So this means we just did negative exponents yesterday. That's 4 times 1 over 10 to the first. Well, I know most of us prefer decimals. What is 1/10? 1/10 is 0.1. What's 4 times 0.1? 0.4. So over here in the original problem, the decimal point was behind the 4. Now it's in front of the 4. How did it get there? It went once to the left. Why? Well, 1, because you have the exponent of 1, but now we have a negative, so when we have a negative exponent of 10, that tells us to move it to the left. One more negative, and then we'll summarize what we're seeing here. 1.23 times 10 to the third. This is 1.23 times 1 over 10 to the third, based off of everything we just did with negative exponents. And again, for those of us who like decimals better, 1 over 10 to the third, that's 1 over 1,000, which is 0.001 tenths, hundredths, thousandths. And if you multiply those together, you get 0.00123. Again, look at your answer, if this thing would not be blurry. And then look at where, the decimal was originally. It was between the 1 and the 2. Well, it had to move 3 places and to the left because it's a negative. So I went 1, 2, 3 to get to my final answer. So when you're doing problems like this, you actually don't have to do out everything that I did in orange here. Let me show you. Rules for multiplying a number by a power of 10. If the exponent is positive, move the decimal point to the right. So let's go back and show you really quick how you would do 1 and 2 without really any work. So my exponent of 10 is positive. It's a 2. So that means I move it to the right 2 spots. So I have 5. The decimal spot is there. I have to move it 2 to the right to get 500. For 2, where we had 8.23, the exponent is 4. That means you have to move the decimal 4 to the right. 1, 2, 3, 4. And you put the zeros in to the empty spots. We get 82,300. Same answer. Let's look at your second rule. If the exponent is negative, move the decimal point to the left. So like we mentioned here in number 3, you have the number 4. The decimal point is right after the 4. It's a negative 1, so that means you have to move it once to the left. Your answer is 0.4. Okay, remember a negative exponent does not mean a negative answer. Number 4, 1.23. It was times 10 to the negative 3. Because it's negative as an exponent, it tells me to move it to the left 3 spots. 1, 2, 3. That's how I get 0.00123. So again, the goal is actually not to do all of this work right here, and rather to do what I just did in the blue. All right, let's continue on with our lesson. To actually, well, what is scientific notation? So we can write really big and really small numbers using scientific notation. And so here's how you actually do it. A number is expressed in scientific notation when it is in the form A. Oh, great. I did a great job boxing that in. Let's try that again. This happens when I look at my phone and not the paper. A times 10 to the n. A is some number that could be as small as 1, but it could go all the way up to 10, not including 10. So basically it's between 1 and 10. Could be 1, but could not be 10 because we don't have the equals to there. N has to be an integer. Remember, an integer is a positive or negative number with no decimals or fractions. A lot of you like to say whole numbers and their opposites is a good way to describe it. So let's jump into now. So we just did writing a number in standard form. Now you have to write it in scientific notation. Don't confuse standard form with the standard form of a line. We're not doing lines here. Okay. So scientific notation, I wrote some steps to help, which of course I'll post these on the classroom, but let me verbally go through these. And then of course I'll actually do these steps. Steps to help you write a number in scientific notation. Move the decimal point after the first non-zero digit. Step 2, find the power of 10 by counting the decimal places. When the number, the number in the problem, is greater than 1, the exponent of 10 is positive. When the number in the problem is between 0 and 1, the exponent of 10 is negative. So just reading those right now might be a little bit overwhelming, so let's actually apply those to a problem. So number 5, you have the number 5,800,000, and I want you to write it in this form right here. Okay, so step 1 says, come on and focus, move the decimal point after the first non-zero digit. So the decimal point right now is right there, and you have to move it to be after the first non-zero digit. Okay, also remember A has to be between 1 and 10. All right, so some of you reading the directions that your book gives that's a little confusing. Move the decimal point after the first non-zero digit. Some of you might think about moving it to here and calling that 58. And when they say move the decimal point after the first non-zero digit, they're really meaning one more. Plus, there's a reason why I can't put it here at 58, because 58, okay, is not between 1 and 10. So a lot of people will just look at this number and say, hey, I have to move the decimal 1, 2, 3, 4, 5, 6 spots, and I need to stop in between the 5 and the 8. Okay, come on. If you went one more spot and put it in front of the 5 for 0.58, 0.58 is not between 1 and 10. Okay? So step 2, find the power of 10, so remember we're going to say times 10 to some number, by counting the decimal places that you moved. So I like to do these little waves. So here I'll count again. 1, 2, 3, 4, 5, 6. Okay, so that's step 2. I had 6 spots. So when the number is greater than 1, so 5.8, is that bigger than 1? Yes. So we're doing step 3. The exponent of 10 is positive. So that means I have 10 to the 6th. And that is my answer. This is in scientific notation because my A is between 1 and 10. 5.8 is between 1 and 10. N is an integer. I'm good to go. All right, let's try number 6. We have a decimal. Move the decimal point after the first non-zero digit. Again, they're looking for you to do this. 1, 2, 3, 4, 5. So I'm going to write that as 7.6. Okay, again, step 2 was to count the number. What did I say, 6? What did I say? I don't even know. 1, 2, 3, 4, 5. Sorry, 5. So I counted. That was step 2. There's 5. All right, so when the number is greater than 1, the exponent of 10 is positive. I need to backtrack on what I just said about these steps. I'm sorry, these directions from your book aren't the best, and they're not very specific. So when the number, they're saying, I apologize for the confusion. They're saying the number, oh no, I did say that. In the problem, the number in the problem. Did I say that? I wish I could pause this thing, but the media that I am recording this on does not let me pause. Anyways, this number is the 5,800,000 and the 0.000076. So back to number 5, because 5,800,000 is greater than 1, the exponent is going to be positive. For number 6, your number was 0.000076, which is between 0 and 1, so we're going to have a negative exponent. And how many places did we move? 5. So I'm going to clarify this and say number in the problem. I think I said that when I recorded it, but maybe I didn't. So I apologize for the confusion on that, but in the problem. All right, let's look at 7. So again, we move the decimal point. It's right here. We're going to move it in between the 3 and the 9. So I'm going to get 3.9. Okay. The number in the problem, 1,000 million billion, 3,900,000,000, that number is greater than 1. So that means my exponent of 10 is positive. I just have to figure out how many spots that was. So again, how many spots did I move? 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's 3.9 times 10 to the 9th. Number 8. Going to move the decimal again. 1, 2, 3, 4, 5, 6 to 3.5. The number in the problem, the original problem, was 0.000035. That's between 0 and 1. So that means my exponent of 10 is negative. Just how many are, here I am. I lost count. 1, 2, 3, 4, 5, 6. So it's negative 6. Okay, we'll have some practice on that tonight. All right, and so the last thing that we have here is applying properties that we have looked at to scientific notation. So here we go. Use scientific notation to evaluate. So this is the benefit of using scientific notation and not having to punch in a bunch of zeros. I know some of you would rather use a calculator to do this, but guess what? Some calculators can't handle numbers this big. Okay, so your first step is to think of 400, and I need to write that in scientific notation. Okay, so let's go through what we just did on the last page. I have to move the decimal point to behind the 4. So it's going to be 4 times 10 to the what? Well, 400, come on, is bigger than 1, so my exponent is going to be positive n, and I moved it twice. Okay, now let's rewrite 2 billion. So I have to move the decimal point 1, 2, 3, 4, 5, 6, 7, 8, 9 spots to get 2. Okay, and 2, what did I say? 2 billion is greater than 1. And we moved it 9 spots, so it's positive 9. Again, we want you to get credit for these problems. You have to show your properties of exponents. So really what's going on here is you just have 4 times 10 squared times 2 times 10 to the 9th. I just took the parentheses away. And now, using your commutative properties of multiplication, we just multiply the numbers that we can. So 4 times 2, that's 8. 10 squared times 10 to the 9th, that's using your properties of exponents when you have the same base. So I keep the base and I add the exponent of 2 and 9. 2 plus 9 is 11. And that's how we would like you to leave your answer. Please don't write it out with the zeros. Let's look at number 10. So I'm going to rewrite this one in terms of scientific notation. So we're going to have to move it 1, 2, 3 spots to get 2. It's going to be 10 to the positive 3 because 2,000 is bigger than 1. Okay, now here I have to move it 1, 2, 3, 4, oh my god, 1, 2, 3, 4, 5, 6, 7, 8, 9 to get 3. Again, it's going to be a positive power of 9 because 3, it's the same as the other one. 3 billion is bigger than 1. So again, to rewrite this for people, this is 2 times 10 cubed times 3 times 10 to the 9th. I multiply the ones that I can. 2 times 3 is 6. And now I multiply my like bases. 10 cubed times 10 to the 9th. I add 3 plus 9 to get 12. And you want to leave it in scientific notation. Let's look at some division ones. So when you have a scientific notation divided by another number in scientific notation, you want to group together the two numbers. And yes, you can use a calculator to figure out what 4.8 divided by 1.6 is. That answer is 3. So again, you want to type that into your calculator and get 3. Now, you want to show us your properties of when you're dividing the same bases. Remember, this is 10 to the first. So when you have a base divided by the same base, a 10 divided by a 10, you keep the base of 10 and you subtract the exponents. So 3 minus 1 is 2. That's your answer. Last one. Same deal, you want to group together the two numbers and you want to use your calculator to divide 7.5 divided by 1.5. When you do that, you get 5. And then I'm multiplying by, okay, we have same bases again. So when I'm dividing the same base, I keep the base of 10 and then I subtract the exponents. 7 minus 4 is 3. And that's it. Thanks for watching.